Hey, welcome everybody. In this video we're going to cover 3 mistakes that are commonly taught in mathematics classrooms, as well as how to handle them correctly. Which brings me to a quick message.
Disclaimer. This video is meant to educate and entertain, like sorta, not to spill tea or throw shade. Many mathematics teachers handle the topics we are going to address perfectly correctly, including my own high school teachers. That said, in my experience, these types of mistakes are prevalent among college algebra and calculus students, at least in the US. So let's address these fundamentals correctly, here, together.
In this video we'll address the following 3 mistakes. The definition of absolute value of x is the distance between x and 0. The square root of x squared is x for all real numbers x, and the general use of the phrase, the function f of x. Before we get going, you can go ahead and hit the like button so we make more of this content, and subscribe so you catch our latest videos. If you need a tutor for any maths courses or test prep this summer, we do offer 100% remote services. Check out the links in the description and join our mailing list for a discount on your first session, schedule a session right away through our booking site, or get more info about the company and our services via our company website. Alright, let's do some math. First up, the absolute value. The issue here is subtle. After all, it is true that the absolute value of x is the distance between x and 0. So what's the problem with saying that this is the definition? This is where fundamentals come in. We need to clarify our terminology and notation. And actually, these 2 things should be among our top priorities anytime we're learning math. So here there's an issue because of the notion of distance. The typical definition of distance, for instance on a number line, uses absolute value. The distance between x and y is the absolute value of the difference between x and y. Sometimes we say the absolute difference. So if this is how we define distance using absolute value, then we can't define absolute value using distance. That's like using the word to define itself. Like if we say a penguin is a bird that's a penguin. Well, yeah, that's true, but it's not a very good definition of a penguin. So what else do we know about absolute value that could be more definitive of what it means? We know it doesn't affect positive numbers or 0. If you put a positive number or 0 into the absolute value, you're just going to get that number back. However, if the number is negative, we know the absolute value switches its sign and makes it positive. So we need to express these 2 cases without using the notion of distance. One of the tools that we have in our algebra tool belt is a piecewise function. Suppose x is any real number. We'll say the absolute value of x, which we denote as usual with the vertical bars around x, is given as follows. If x is greater than or equal to 0, then the absolute value of x just equals x. But if x is negative, if x is less than 0, the absolute value of x equals negative x. Negating the negative number is how we get a positive out of the absolute value. So the correct way to define absolute value is in cases, or another way of saying that is as a piecewise function. In the case that x is greater than or equal to 0, the absolute value of x is just x. In the case that x is less than 0, the absolute value of x is negative x. So let's verify that this does what we expect with an example. If x is 7, then x is greater than or equal to 0. In that case, the absolute value of x is x, which is 7. So the absolute value of 7 equals 7. As expected, great. If x is negative 7, then x is less than 0. In that case, the absolute value of x is negative x. Since x was negative 7, that gives us negative 7, which is 7. The absolute value of negative 7 is positive 7. Again, as expected. So this is how an absolute value changes a negative number into a positive one by way of a piecewise action. Okay, so let's extend this a little bit and talk about why anyone would care. So here's a theorem. Suppose that c is greater than or equal to 0. Then the absolute value of u equals c is equivalent to the equation u equals plus or minus c. The double-sided arrow means that if we know either equation is true, we can rewrite it as the other equation. So one reason this is helpful is because it tells us how to solve absolute value equations. It tells us how to remove the absolute value that we see around a variable in an equation like this. But how do we know this is true? We can actually use this definition, this algebraic definition of absolute value to prove this theorem. Okay, now, this is a pro-proof channel. We're not going to shy away from doing these proofs, but we can handle it just using the tools that we've already discussed. So, we'll assume that c is a number greater than or equal to 0, and that the absolute value of u is equal to c. The first case is that u is greater than or equal to 0. In that case, the absolute value of u is replaced with just u. Now we have u equals c. In the other case, u is negative. When that happens, the absolute value of u is replaced with negative u. We want to solve for u, and so u is equal to negative c. And that's it. We proved that if c is a non-negative number and the absolute value of u is equal to c, then u is equal to plus or minus c. Now technically, to prove the entire theorem, we would need to prove the arrow that goes in the other direction as well, and assume that u is equal to plus or minus c to show that the absolute value of u equals c. I'll leave that to you all to do, but it's very similar to the example we did on the previous slide. We would use the absolute value definition to show that regardless of whether we put plus or minus c into an absolute value, what we get out is the positive version, that is, we get out c. So let's actually use this to solve an equation. Here's an example. The absolute value of x minus 5 equals 3. So here's our equation. First step is to remove the absolute value around x minus 5. Basically, we're thinking of x minus 5 like u in the theorem. If we remove the absolute value, we have to put a plus minus on the other side of the equation. This actually gives us two different equations. X minus 5 equals plus or minus 3. We can write as x minus 5 equals negative 3 or x minus 5 equals 3. And we solve both of these equations. The first one on the left gives us x equals 2. The other equation on the right gives us x equals 8. And so the two solutions to this equation are x equals 2 or x equals 8. Great work, everybody. So that's mistake number 1, which we've corrected. Now we know that the absolute value of x is defined in a piecewise form. You can check out part 2 to see the next common mistake, how to correct it, and how to extend it a little bit, that the square root of x squared is equal to x for all real values of x. Don't forget to like and subscribe. I'll see you in the next one. Take care, everybody.